Welcome to this explainer. Today, we're decoding exactly how network and data cable tray systems literally determine the life or death of your structured cabling architecture. I am super excited to guide you through this. Look, the physical backbone of modern infrastructure usually flies way under the radar, but getting your pathways right from day one, it's absolutely critical.
Because the stakes are incredibly high here. If you get the pathway wrong at the design stage, your system doesn't just underperform, it turns into a massive, costly, unmanageable retrofit nightmare, instead of something you can easily maintain for years. Think about it. We rely on data more than ever, right? And the physical pathways carrying that data dictate the health of your entire network. A well-designed tray system means everything runs smoothly. A poorly designed one? You're basically looking at a structural entanglement that's going to cost a fortune and cause a lot of headaches to fix after the fact.
So here's our roadmap for building a bulletproof pathway design. We're going to cover matching trays to zones, calculating cable fill ratios, EMI separation, overhead versus underfloor routing, and finally, meeting global cabling standards. Let's jump right in.
Moving to our first pillar, matching trays to zones. You really can't just use a one-size-fits-all approach here. You've got three distinct critical zones to match your trays to: the backbone, horizontal distribution, and zone distribution. It's kind of like a highway system. The backbone is your network's main interstate, carrying massive amounts of data. Then the horizontal distribution routes those cables out to specific regional areas. And finally, the zone distribution manages the localized street-level connections. Matching the right hardware to the right zone, that is your very first line of defense against network congestion.
All right, next up, we're tackling the math behind cable tray capacity for Cat6a and fiber optic cables.
And there is one absolutely crucial number you need to remember here: 40%. The BICSI TDMM, which is essentially the global gold standard for telecom design, dictates a really strict 40% maximum fill ratio. And why is that? Well, because pushing past that limit introduces a very real danger of cable crushing. That's where the sheer weight of the cables actually damages the data lines sitting at the bottom of the tray. Plus, when cables are packed that tight, they completely choke off airflow. That trapped heat is going to seriously degrade your network's performance over time.
To put that into perspective, just think about the vastly different physical footprints you're dealing with. Standard Cat6a cables are thick, they're rigid, and they eat up tray space incredibly fast. Fiber optics, on the other hand, are super thin and let you achieve really high density. But hey, don't let that fool you. Even with high-density fiber, you still have to run the math meticulously to make sure you aren't violating that 40% rule. The specific cable type always has to dictate your calculations.
Moving right along to Part 3, EMI separation and managing data alongside power trays.
Now, physical distance is a fantastic insulator against electromagnetic interference, so maintaining strict separation between your data and power trays, that's the ideal scenario. But let's be real. In actual facilities, space is at an absolute premium. When your physical footprint is severely limited, dropping a grounded metallic divider right inside a single tray is a completely acceptable and highly effective alternative to shield your precious data from power line noise. It's a real space saver.
Okay, Part 4, the great debate: overhead versus underfloor routing in modern data centers.
When we analyze MAC time, which stands for moves, adds, and changes, and we look at thermal risks, overhead routing is pretty definitively the current industry standard, and it makes total sense when you think about it. Underfloor routing notoriously blocks cold air pathways, which creates dangerous thermal risks for your servers. Overhead routing drastically reduces those cooling issues. And on top of that, it significantly speeds up your MAC time. Just imagine the difference between easily reaching up to a visible overhead tray to drop in a new line versus the incredibly labor-intensive headache of ripping up heavy floor tiles just to see your cables. Overhead routing is just plain more efficient.
Finally, Part 5, meeting global cabling standards to ensure compliance and scalability.
And this brings us to the actual hardware reality, specifically Shanghai's Xinma busway and cable tray. They are a true global standard bearer, providing that highly reliable infrastructure you absolutely need for massive data centers, rail transit systems, industrial plants, and complex commercial buildings.
Let's look at what they actually build. Xinma manufactures a really comprehensive suite of mission-critical solutions. We're talking standard cable tray systems, heavy-duty busways, crucial seismic bracing to protect your gear against earthquakes and environmental threats, and intelligent cable management systems to keep your architecture totally future-proof.
And crucially, these products don't just exist in a vacuum.
They comply with the absolute highest global manufacturing standards, IEC 61537, NEMA VE1, BSEN 50085, and GB 31251. Adhering to this rigorous alphabet soup of international regulations is literally what ensures that, whether your project is right down the street or halfway across the globe, your foundational infrastructure is secure, compliant, and built to last anywhere.
So, I'm going to leave you with this final, critical thought for your next structured cabling project. Take a good, hard look at the pathways you're drawing up today. Are you building a structured, scalable pathway that is totally ready for tomorrow? Or, by ignoring fill ratios and proper zone matching, are you accidentally engineering your very next costly retrofit nightmare? Thank you so much for joining me for this explainer, and I really hope this helps you design your next system with total confidence.